What is up, everybody? I'm back. Welcome back. Hope everybody is well. Roman, how's it going? How's your day going so far?
Oh, good. Hello, everyone.
Awesome. So, a little bit of housekeeping before we start. Last week, I was away and I was at FinOps X. I think I have a sticker, FinOps X from the other day. Really great conference. Had the best time. Met so many of you guys out there, some great fans who came to chat to me about the show. So I'm glad it's reaching the right audiences and you are enjoying it. As always, if you have any questions or comments and you want to come on the show or any feedback, feel free to email costoptimization@amazon.com. But if you are wondering kind of what the highlights, what did we learn, how did the event go, don't you worry. Me, Ali Whitman and Aaron Adele, who have been on the show multiple times, are going to come back together and we're going to have a nice little chat about the event and all the stuff I mentioned before. So make sure that you subscribed on YouTube to catch that, because that's not going to be streamed on Twitch. That's just going to be a YouTube special. All right, enough about that. Let's get into the show we're doing today. So welcome everyone to the Keys to AWS Optimization, the show where we share stories, concepts, and solutions to help you unlock your spend at AWS. My name is Stephanie Gooch, and I am a Senior Optimization Architect in the Optics team, helping all of you with your optimization journeys. Roman, do you want to give us your 1-minute origin story?
Oh, yeah, sure. My name is Roman Boyko, and I work as a specialist solution architect for serverless technologies. That means that I deal primarily with AWS Lambda, API Gateway, SNS, SQS, and I work with DACH customers in Europe and help them to build new applications or to modernize existing ones and move to a serverless first approach. And I've been almost 5 years in AWS. In 1 week, it will be 5 years already.
Ooh, 1 week away from the orange badge.
Yes.
Jealous. That is the goal. For people who don't know, once you've been here for 5 years, you get an orange badge. As you go on and on, you get different colors. Check out the Jeff Barr episode, because I think he's done 10 or 20. He must have done 20 years, and he has like a silver badge.
So silver, yeah.
Yeah. Check out the YouTube channel to look back on that episode. Okay, so serverless. I am super excited to talk about this because we mentioned moving to serverless as a way to optimize all the time. But today we're going to get into some nitty gritty, mainly 2 points. 1, how you optimize your Lambda functions, and 2, other serverless architecture. So we'll break those 2 down. But Roman, do you want to give us like a quick overview of Lambda and then dive into how we can optimize it?
Yeah, sure. If you don't know, Lambda is probably first service when AWS announced it. We came to this notion of serverless. Although there were some serverless which fit the paradigm before, but no one realized that. And the main idea about Lambda is that it is a compute service which allows you to run your code in response to different events. And why it's serverless? Because you don't need to manage the underlying infrastructure, so that you don't have to deal with servers yourself. It is done by AWS for you. So you just need to write the code and then configure some parameters, and we will provide the infrastructure to run those code. And we will automatically scale up and down depending on the load. And we will also provide security and availability options. So yeah, it's an amazing service to run your code.
Yeah, it is. I use a lot of Lambda now. I haven't logged into an EC2 in probably like 4 years. Someone was talking about that the other day, and I was like, oh no, I don't remember. Like it's been a long time, and so I just use Lambda for any kind of code I run. So if you are kind of new to that world, check out a lot of the AWS getting started guides, and they can get you started on it. But let's focus on the cost. And something we spoke about a bit before this session was the cost versus performance element of creating Lambdas. Do you want to touch on that?
Yeah, first of all, we need to understand how Lambda is built. So there are 2 dimensions. The first, the number of requests. So the more requests you issue to the Lambda service, the more you will pay. And the second dimension is gigabytes per second. So the only configuration option for the Lambda function you have is memory configuration. and the duration of the function. So memory times duration, it is gigabytes per second, and the longer your function is running and the more memory you assign to it, the more you will pay. But here's an interesting thing, because amount of memory you gave to the function also influences the amount of CPU power you will get in that function. And surprisingly, sometimes if you assign more memory, you might think that, yeah, I will pay more. But sometimes if you have a compute-intensive workload, that essentially means that your function might run faster and spend less time executing, and it will give you better cost results. And just to give you an example, for example, I have a function. I assigned it 1 gig of memory, for example, and it was running for 200 milliseconds. It will be the same amount of money and the same cost if I have the same function. I assigned 2 gigs of memory, and it was running for 100 milliseconds. This is important to understand, because if I give more memory and function runs faster, then I pay less, because sometimes people think that, yeah, I will give the less amount of memory to the function, like the minimum is 128 megs, and yeah, I will pay less. But if it runs longer, then yeah, sometimes you will pay more compared to if you give more memory to the function.
Is there, and I think thank you for breaking that down. I was trying to formulate a metaphor in my head, because I love a good metaphor. And I was kind of thinking about, if you had a bike, which is a cheaper thing to own, it would take you to cycle like 100 miles would take you a lot more time to do it, and you'd be a lot more tired at the end. Whereas if you have a car, it's more expensive, but you'll get there a lot faster. So that's kind of an analogy for it. Roman's like,
yes, to some extent. But there's a great tool which allow you to get an estimation how to configure your function. It is called AWS lambda power tuning. It's an open source library created by one of our colleagues. And what it essentially does, it just takes your function and runs this function with different memory configurations, and then builds a graph where you can find the best option, so in terms of performance and cost. And another very interesting thing to know about Lambda is that probably you already know that we have different CPU architectures on AWS. We have our own ARM Graviton, ARM-based processors called Graviton. And in Lambda, you can also select whether your function will run on a x86 architecture or on ARM architecture. And in general, we observe that if you run on ARM or on Graviton architecture, you will get better price performance characteristics for many workloads. And here's another thing I wanted to mention, that with Lambda, it is probably the easiest way to try out Graviton and ARM architecture, because you may have the same code, especially if it's not compiled code, something like Node.js or Python. You can just switch one option in the Lambda configuration and run the same code on ARM and x86 and compare. And this power tuning library also allows you to compare different architectures and find the best cost performance option.
That's cool. I mean, you beat me to it. I was going to jump in before you started talking about that, saying, how do people figure this out? Because it's quite the balancing act of the power versus, or like speed. The cost versus performance, is something quite complex. But Amazon's already helping you out with the power tools. And I think we should get someone to maybe we should get you back on to do a demo of that, because that'd be quite cool to kind of see how that architecture plays out. And then definitely just talking about the Graviton stuff, guys, I mean, to echo what he said, it's so easy to flip that, especially if you have infrastructure as code. It's in the architecture part. And I think that was something that it took me a little while to figure out where the change is. And if you're using CloudFormation or Terraform, there should be an architecture parameter. And that's the one that, parameter. Change that to ARM. I'll find the link and I'll share it after as well. But that's just like, and like you said, if you're using any of those non-compiled code, test it out. Get it for free. I had a good conversation with someone at London Summit who was a developer who just was like, we were just chatting about some other stuff. And he's like, I was like, do you do much cost optimization? And he was like, I'm on Lambda, so I don't need to. And I was like, well, actually, hopefully he sees this episode. Before we move on, someone's had a question. So if I pull this up. So thoughts on power tuning versus compute optimizer recommendations. Do you have any kind of comparisons of when to use which one?
Yes. They work differently. First of all, power tuning allows you to make an estimation and first assumption when you create a new function and you don't know how much memory will be the best option for this particular function. So you may run power tuning for that and get the first assumption. While compute optimizer, it works differently. It collects statistics for already running functions in your environment. So probably you already deployed the functions into production or run some tests in a test environment. And then compute optimizer collects the statistics for those running functions, and then it gives you recommendations that, probably you also misconfigured some functions. So I would recommend using both power tuning for the initial assumptions and making the decision, and then compute optimizer for proving that, these assumptions were correct and based on real life usage, you probably can further optimize your Lambda functions.
Awesome. I mean, thank you for asking that question, by the way, because that's a very good point of how there's a difference between the planning stage of a build and the review stage of a build, and they're like two different things. And so that, you can use these for different things, because the power tool will give you that estimate, but you've got to see how things are working, and you've got to see if actually how efficient your code is and if you could change it. And you might have changed it since that first time that you've run the power tool over it, and you can kind of configure different things. Just another thing, there was someone asking in the chat about KMS calls. I don't think that's relevant to this conversation at the moment. However, I popped a link in the chat about how to optimize it. But if that doesn't answer, feel free to add more context and we can try and sort it out. Otherwise, just pop me an email at costoptimization@amazon.com. Okay, so before we move on to talking about other serverless architecture, is there anything else you wanted to cover with optimizing Lambda?
Probably there are a couple of other things I wanted to mention. We quite recently released SnapStart for Java, and it will probably not directly affect the cost, but it is a great improvement in performance for your Java Lambda functions. And another very important thing I wanted to mention is because we want to minimize the runtime, the time of our functions. Evaluate different options because there are different languages you can create your functions. And sometimes I see, and I know some customers, they optimized their Lambda functions rewriting or using compiled languages like Rust or Go, and they got a great boost in performance, and the faster your function runs, the less you pay. So you have both price and performance improvements.
That's really cool. I hadn't even thought about that. That's amazing. I mean, if you want to get those customers on here to share that story, I mean, that's really cool. So yeah, people out there, like the person I spoke to at the summit, just because you're using Lambda doesn't mean you're at the most optimized you can be. There's so many more things you can do. And isn't there, the name has escaped me now, a tool which analyzes your code to tell you how to be more optimized? Code. I'll Google it. I definitely, it's one of those things that's like, I have it written down on a plan. I've just got to find the plan. Okay, cool. But yeah, that's very interesting. So try moving to a different language and see if you can optimize that way. Love it. Anything else on before we move on to other serverless architecture?
Probably another very interesting thing you may consider is event filtering. For example, if your Lambda function consumes events from SQS or Kinesis or DynamoDB stream, you can, in many cases, you don't need all the events or all the messages to be processed. And usually how you implement that, you put an if statement in your function and filter out unnecessary messages. Quite recently, we announced an event filtering when you can filter out the unnecessary events and messages before they invoke your Lambda function. And so only events or messages which are of value and you want to process those messages, they will filter, they will invoke the Lambda function. And here, a great thing is that it comes with no additional cost. So all the filtered out events which are not invoking your Lambda function, you don't pay anything for that.
Oh, wow.
That's great.
Oh, that's awesome. Okay, so many little things there. And when you're working with your customers, just taking a step back from doing this optimization, the actual efforts of reviewing the code, is there anything when you start, like if someone stays like, okay, I want to go and optimize my Lambda function, but they have 1,000 Lambda functions to look at, where would you start them off at?
Usually, I start with this memory configuration options, because I see a lot of customers, they not misunderstand, they don't configure those memory options right. They just make some guess. Then I will go with 1 gig.
Finger in the air.
And yeah, probably it will be enough for all the functions. So this right sizing mechanism is the crucial one, and I usually start when someone comes to me and start complaining about the cost of the Lambda functions. The first question I ask, how you determine the memory configuration for your functions. So this is the first thing we usually look into. And then yeah, compute optimizer is a good option. Then another things like how you do login, because sometimes the Lambda is not the most expensive service in your overall serverless architecture.
Okay, cool. All right, yeah. So you heard it here. If you are looking at that Lambda fee and thinking, could I make this any smaller? Then check that out. Also, I 2 things. One, shout out to Eric, Code Guru. That was the service that we couldn't think of. So check out Code Guru, and I've popped a link in the chat as well, which you can have a look at that. And the other thing I forgot to mention at the start was, if you are looking to shift to serverless, lift to shift, kind of here's a blog series that I found that's all about how to do that. So if you're inspired by today, then you can check that out. Awesome. So many good tips. Thanks, Roman. I've really enjoyed learning about this. I'm going to go away with my customers and start to dive into this with them for sure. Okay, so as we said at the start, serverless architecture doesn't just mean Lambda. I think that's kind of what people think of first. but there are a couple of other services that have this. So should we dive into some of those as well?
Yes, sure. I already started talking about login and metrics, and especially with metrics, Lambda produces some metrics for you, but in many cases you will need some business metrics to also look into specifics. There's a good thing to know. If you need to produce metrics from your Lambda functions, there's and if you look into the documentation, you will probably find that there's a put metric API call for the CloudWatch. Don't use it because it is very expensive and it is synchronous. So you will pay for each call or for put metric call, and you will wait until this call is succeeded. So you will just waste time and money running your Lambda function. There's another option how you can produce custom metrics from your Lambda functions, and it is called the embedded metric format. And essentially, you need to create a log entry from your Lambda function in a specific format for CloudWatch, and CloudWatch can then pass that log entry and extract metric data out of that EMF record and create a custom metric. But from the developer standpoint, it might look quite hard to produce that EMF format because it's a huge JSON structured log with a lot of parameters. There's a simplification thing which help your developers to produce those custom metrics with EMF, and it is called Lambda Power Tools library. And this Power Tools library, essentially, it's a set of different things which simplifies how you can produce metrics, logs, and traces from your Lambda functions. And we created those for different language runtimes like Java, TypeScript, Python, .NET. And yeah, I highly encourage looking into this Power Tools libraries. And yeah, this is for Python. We have for Java, for TypeScript as well. And awesome. It does this EMF automatically. So you say, I want to produce a custom metric, and under the hood, it will create this EMF for you and produce that custom metric. Or if you want, for example, to have structured logs from your Lambda function, it can also produce structured logs, and it can also do some other useful things. There are tons of different functionality. So yeah, I highly encourage looking.
Okay, before we continue, I messed up. So when I was pushing links out, I shared the wrong one first. So just to clarify, there are there's because there's they're very similar names. So there's power tuning, and then there's also power tools, right? They're two different things. Okay, so my bad. Everyone watching, if you're watching on YouTube, the links below will be the right order of links. But number one, power tuning. Number two,
power tuning tools. For determine the memory configuration, and power tools for login metrics and many other useful stuff. Yeah.
Power tuning, this one. Okay. Apologies, everyone. God, the link smacked it up. Okay. Sorry about that. Quick anecdote. All right, let's keep going. So, and we've still got about 5 minutes left. So anything else you want to mention?
What else? There are plenty of other things you can do. For example, you can look at how you do caching, for example, with, again, different services like API gateway,
Okay.
lambda functions, etc. So that will also help you to optimize the cost. And what else?
So we're going back on the caching. So is that I'm assuming caching information in your Lambda functions so that if they keep running, there's stuff that they'll remember?
Yeah. So there might be different layers of caching. So you may start with caching some data on CDN, on CloudFront. Then you may cache some data on the API gateway, so that it doesn't come directly to your Lambda function and invoke your Lambda function for each invocation. So and then cache some data inside Lambda function as well, so that you don't make unnecessary calls to the downstream services or something like that.
Cool.
What else? Another quite powerful thing you can do to optimize costs. Do you need to call Lambda functions all the time? Because there are direct integrations between different AWS services. So, for example, if you have an API gateway and this API gateway needs to store some data in a DynamoDB table or an SQS queue, there's a direct integration between API gateway and the other AWS services. So sometimes you don't need a Lambda function in between. And the general recommendation here will be don't use Lambda as a transport layer. If you want just to put a message or some data from your API gateway or from AppSync to DynamoDB, sometimes you can do that directly without calling a Lambda function. If you need to run some business logic and do some sophisticated transformations before you store the data, then yeah, for sure you will need to run a Lambda function with your custom code. Another interesting thing, we have step functions. It is a tool which allows you to automate workflows and build state machines. And quite often I see that customers, they use Lambda functions and call from their state machine Lambda functions just to make another call to another AWS service. Step functions also have a lot of direct integrations with more than 200 AWS services. So you may call those services directly from step functions without calling a Lambda function. So
totally removing the Lambdas altogether is also a solution.
Yes. You don't call that Lambda functions. Another thing to remember, if you want, for example, and feel the urge to call one Lambda function from another, don't do that. It's, again, not a best practice because not only because you couple those functions, but the first function, if you make synchronous call to the second function, it will just wait for the response back, and you always pay for the time your Lambda function is running. If you need to chain some Lambda functions and orchestrate them, again, use step functions. You just call the first one, get the result, and then in your workflow call the next.
That's just to finish off, there was like I always mention this story, this concept of like Lambda looping, which is what I've called it, but I don't know if that's the right term, but the idea of being that a Lambda function is invoked, it then does something, sends something to another Lambda function, and then somehow that second function then triggers the first again. And then this endless circle of running Lambdas is happening, and you're paying for every single time this happened at my company. And because Lambda is, I mean, don't get us wrong, guys, we're telling you how to optimize a service, but it's not, depending on how you use it, it's one of the ones that I often see quite low down on people's spend because it is quite a cost-effective service. And so when it comes to this kind of optimization work, it's often one of the later ones that gets utilized or looked at to be optimized. And so it's quite interesting, that situation when we had it, no one even noticed that there was that running for ages, because in comparison to like EC2 or RDS, it was such a small spend. But in itself, they were like, why is this so expensive? We only have like 2 functions. Oh, we have 2 functions. And 2 other situations that happens, I think I mentioned before, is S3 loop. So you put an object in S3, there's an event notification that triggers it and passes it, and it keeps going. And then the second one is with SQS queues. So you put a message in the queue then passes it back. So, and I swear most of these are probably done because someone has pasted the wrong Lambda function ID in the like next part of when they're creating their SQS messaging, they've probably pasted the wrong name of the function. So stuff like that. Awesome. All right. I think we're at time. Also, Roman, thank you so much. So many great tips. As I said before, this will be on YouTube. You can check out all the resources below. So much fun. And I'm looking forward to diving into some more of it myself. Next week, we have Savannah, who will be chatting with Matty and Rick all about right sizing and going into a deep review of how right sizing can be fun. And we'll see you guys next week. And thanks again.
See you. Thank you.